Yeah, ladies and gentlemen, thank you for coming tonight. I'm very honored to present you the first speaker, Mathias. He came from Copenhagen. Wir sagen hier Kopenhagen, yeah, Copenhagen. Copenhagen, yeah. So we have a very traveled speaker. And I first saw Mathias, who confirms on Twitter the Macintosh, last year on the JSConf EU in Berlin. And I was so impressed about his talk. And to me, it was the best talk I saw at the conference.
Thank you.
And I took the courage, and asked him whether he would take the time to come down here to us, to Munich, and share some of his latest hacks with us. And so I'm really honored that he's here to talk about pipe streams and distributed systems. So please give him a warm welcome. Macintosh.
I just found out that I suck at computers trying to set this up, but it's fine. All right, cool, thank you. First of all, if any in here has a MacBook and he or her has Xcode installed and he wants to help me, raise your hand. If not, it's also fine. All right, have you ever compiled anything before on a MacBook? All right. Just while I do my talk, if you can try running this command. It's totally safe. It's just a module I wrote. It's because I have a demo that requires 2 computers, and I forgot my computer at home, my second one. And it's kind of hard to get working. So you might have to run this. Or if you have to use sudo, it has. This looks so scary. It's not scary at all. So either the first one or the second one. So if you could just try running that, and at some point let me know if it worked. Otherwise, we'll just get that thing. Thank you. Did you get the commands? Okay, cool. All right. Thank you for coming and taking the time to listen to me. I hope you're also coming for something else. I flew in from the Dominican Republic. I have a friend who lives there, and I was in San Francisco, and I looked at a map, and I thought, that's on the way back home. It turns out it's not, because the Earth is kind of square. So you actually fly like this, and I ended up flying like this, and it took forever. So I'm a little bit jet lagged, so if I say something completely wrong, I'm just going to say it's the jet lag, and it's fine. All right, so I'm going to talk about streams, pipes, and distributed systems. My name is Mathias. I go by Macintosh online. I work on a project called the DAD project, which is a project to make open source distributed tools for versioning data. We're a grant-funded project, and it's a non-profit. It basically means I get to write open source JavaScript involving distributed systems all day long, so that's great. So if you want to talk about any of that, or just Node or anything, just hit me up here or online or whatever. So I like to do these talks where I kind of assume that nobody knows anything, because I think that's more fun. I'm just going to empty my pockets here because they're so heavy. It's just dollars and passports and pesos. It's fine. So let's just take a step back here. How many in here has done Node before? All right. Who in here has published the modules npm? Okay, that's pretty good. We should hang out and install each other's things and run commands. So one thing I really like about Node is streams, right? I think there's something everybody likes about Node is streams. It's something very early on that was in one of the first blog posts that came out was like, streams are cool. So streams in Node are really cool because it's this core abstraction that basically allows you to work with data that's not there, or at least not yet there yet. And also allows you to work with data that doesn't necessarily fit in memory. So like, what do I mean by that? I'll just do this very basic example. Everybody probably already know this, but I'm just going to do it anyway. So in case somebody is too scared to raise their hands, we can all be on the same page. So let's say we have this problem where we have a file on our system. That's a very normal problem. And we want to figure out how big it is. And let's say, just for the sake of argument, that we cannot stat it. We have to, read it. So one way you could do it is like this, right? Probably everybody has probably seen an example like this. You have this really cool call in a Node called fs_readfile, and it's a file it's a file system module called fs, and you call readfile on that, and you pass that a file name, and what it does is it gives you a callback with an error and a buffer. This buffer kind of encapsulates the entire file. It's all the content in the file is in this buffer. So it's very convenient, very easy to do. You can do it in like 2 lines of code. So the only problem is, well, let's say we wanted to read this file to figure out how big it is. So we read it and we console log the length of it. Well, the only problem is, what is this file is freaking huge, right? What happens? So, let's try it. I wrote here that it doesn't work, but let's try it anyway. Maybe it works. So I forgot to do this before, copy a file in here, so I'm just going to do that now. Are we recording this? All right.
Change plan?
No, I'm just going to do it fast then. So I'm watching this really bad show that has a really, that has a don't watch it. It's this kind of thing I started watching on an airplane, and then I kind of had to watch the entire thing, and now I'm kind of stuck with it. Anyways, just going to copy that in here. So we have our huge file here, right? So we can cheat and we can stat it, and we can see it's 249 megabytes. It's not that big. So let's write a script. Let's call it size. Just gonna close this for a second and reopen it, so I don't have a million tabs. So what we can do is we can take that example, read file. I like to code while I present. I hope that's okay with everybody. Almost fits. There we go. If throw right? And let's console log buff.length. All right, so that's the same script I had in my presentation. So what happens when we run this? It works, right? It's not that big. It's 200. Who cares? So let's try to double it. So I'm gonna copy it into a temp file, double it, and let's just keep doing this for a while, because the file was not that big, and I have a lot of RAM on my machine because it's a modern machine. Actually, fun fact: I recently bought the new MacBook, and it only has one port. You know that? So in order to use VGA, you have to use this adapter thing here, right? When I bought this adapter, a friend of mine bought an Apple TV, and the Apple TV was less money than this adapter. And they tried to say like, it has a computer inside or something. I don't even. All right. So now the file is a lot bigger. It's 2.7 gigabytes. So let's try to run this example again. So as you can see here, we get this really friendly error message saying the file is greater than 3 bytes. So that didn't work. We all kind of knew this, right? I actually had that in my comment, so fine. All right, so moving on. We can easily solve this. We can use something called readable streams. So readable streams is something that allows you to, like I said, deal with data that doesn't necessarily fit in memory. So if you wanted to rewrite our example, we could do it like this. We could say, let's make a readable stream to a file that returns a stream. Every once in a while, the stream starts to emit data. And when we get some data, we just update a counter that kind of holds the entire length of the file. And then when the stream is done, we just print it out. So now the example is more lines than before, so it's more complicated, but it still works. So let's try it. Just gonna copy it here and fix my indentation. You have to do that. And let's try running it. Right, okay. So it works, right? We can kind of pretend that we can figure out what this is. It's like kilobytes, megabytes, 2.8 gigabytes, and then I think OS X uses 1024, so it's like around 2.7. It's fine. It's probably fine, right? So as you probably noticed when I ran it, it took a while for it to reply, right? It's still a long-running operation. So I mean, we might have fixed our example. This code might not crash anymore, but it still kind of sucks, right? Because it's doing stuff, and we're not getting any feedback. So if I was a user and this was a program, I would be like, I don't care that it works, because for me it takes forever, even though it's taking 5 seconds. But I'm just sitting there staring at my terminal, nothing is happening. So let's try to fix that. So there's this really cool module on NPM. I didn't write it. A friend of mine did, but called single line log. So what that allows you to do is basically log stuff out to the terminal, but on a single line. So when you log twice, it overwrites the previous line. So what we can do here to make this a lot better is just require that guy, do standard out, and then do log length, and then log length. So every time we get some data, we update our variable and we print out, how far we've gotten, and then at the end we just print it out again just to make sure it's flushed. So now when we run it, oops, it's single line log. So now we always get output, right? As soon as we ran it, we instantly get feedback. That's pretty cool. And we can probably even make this one better. By the way, see, I'm running this NPM offline thing. If you ever spend a lot of time on an airplane, you will figure out that NPM doesn't work on an airplane. And you can do this really cool hack. I'm totally going off script here, but I think this is useful. You can do this really cool hack where you just set the cache min attribute to a lot of numbers, and it works offline. So I'll tweet that afterwards. So let's install this thing called Pretty Bytes, I think it's called. It's also a lot faster when it's offline. We should just always run it offline. I'm going to require that guy. So Pretty Bytes just prints out bytes that are prettier than the other bytes, I guess. So let's just call pretty on that guy. Now when we run it, we have this really nice program, right? That always gives us feedback, and it's nice and easy to read. So it didn't take that much effort, and now everybody wins. So readable streams are great. That's my point. So of course, when you have something called a readable stream, you also have something called a writable stream. And this is my own personal definition of a writable stream. It's just something that you can pipe a readable stream to. Meaning that if you have something that gives you a lot of chunks, like all the time, you have something that you can write a lot of chunks to all the time, and just doesn't have to have the entire thing in memory, right? And readable stream has this really nice semantic called pipe that just sets up this pipe for you, where just every time there's a bit of data on the readable stream, it just writes it to the writable stream. And if you're reading faster than you can write, then it sets up pausing and that kind of thing. So it's really nice, really cool example. So that's cool. So something that's nice and simple is we can copy a file like this if we use writable stream in FS, and we can do that using FS create write stream. So we can just pipe them together. So let's, just for the sake of argument, try to do that. So we have our big file, and we're going to copy it. Oh, the file is still called size. That's a bit confusing, but who cares? So as you can see here, something is happening. And what it's doing now, it's reading that little file chunk by chunk and then writing it. And when it's done, we'll have 2 files. So, we can copy a file in 1 line of code in JavaScript. You probably already knew this, but it's great. I like to show it. So writable streams are cool also. But sometimes you want to do a little stuff with this data before writing it. So this is where transform streams comes in. So transform stream is the stream that's both readable and writable. We also call it a duplex stream. Duplex is a cool word, something I like to say to sound smart. It's the kind of word, if you don't know what it means, you're lost, and if you know what it means, that sounds really cool. but it doesn't really explain what it is. But a transform stream, right? So you get data in, you do something with the data, you get data out. And there's a really cool one in Node called gzip. So you can just require a clib and pipe it through a gzipper, and then you can gzip a file. So just for fun, just try running this. Create gzip. Right. I'm gonna delete the copy thing here. And let's run the example. So if I open a new terminal and go into this folder again, we'll see here that it's writing the file now, but it's just a lot slower than before because it's doing a transform, and my MacBook is slow. It's probably getting harder now. No, not that much. I have no idea how big this file is going to be. Just going to let it go to a gigabyte, and then we're going to move on. So hopefully it's going to be smaller because we concatenated the same file a lot of times. So I have no idea how smart gzip is. Apparently not that smart because it's already a lot larger than the original file. But you get the idea, right? So we can do transforms. That's awesome. So wrapping up, streams are really great for doing stuff like memory management, where you want to deal with a lot of data, but you can't fit it all in memory. And it's also, and the list, especially this last part, is really the thing we always forget. It's really, really good for building low latency applications, right? So building applications that gives us instant feedback, and instant feedback is huge. You don't want to sit around waiting for a button after a second. It feels terrible to a user. So even though actually there's a bunch of Node modules, for example, there's this really cool Node module called JSON Stream that allows you to stream JSON into a parser and pass it while it's streaming. And there are some issues in there. One of the issues is like, this is slower than doing JSON.parse. And of course it's going to be slower because it's written in JavaScript. But for the user, he's getting feedback instantly instead of having to wait a second for the entire thing to buffer. It might take 5 seconds, but it doesn't matter because he's getting instant feedback. So just because something is technically slower, latency matters. So yeah, okay. So we got readable streams, we got writable streams, we got transform streams. This is the thing that too few people are talking about. Transport streams. So what do I mean by a transport stream? It's a duplex stream, cool word, that, and again, this is just my personal definition. It's a duplex stream that just allows you to connect to somebody else, right? So it's basically a stream that I can open up a stream from my computer to somebody else, and I can write into that, and he'll get that message. And he can write into his stream, and I'll get that message. But it's still just a stream. It has the write and on data methods. That's it. So Node Core has a bunch of these. One of the most simple ones is TCP, which is called net for some crazy reason in Node. But that allows you to make TCP sockets. Does anybody in here ever have ever written a Java? All right. Has anybody ever done a TCP socket in Java? So actually, before I did Node, the only other programming language I've done was Java at university, and I remember I had distributed systems, a class, and we had to do a TCP socket. And I remember the code was like, huge, right? And I didn't even do threading. And when I first started doing Node, I tried running this example, and I was mind blown that you could do this and this little code without having it be, dummy code. This is actually, production quality in the sense that you don't have to use any other APIs, right? You don't have to apply threading or anything. So yeah, and we have a client API. We can do sockets. We have a server API where we can accept sockets, and sockets is just a stream still, right? So this is pretty cool. So let's try to do that. Did our thing ever finish? So the gzip didn't work. That's cool. Well, at least it was like the same size. So apparently gzip sucks. Should probably use premium gzip or something. So let's try to build a TCP server, right? So this is just a TCP server that just prints out everything I write to it. And if I run this guy, I can now, actually let's run it up here. I can now just open a TCP connection to my server, netcat NC is just a program that opens a TCP connection. I was running this on 8080, right? And I can write hello in here. That's awesome. I mean, super simple. I can write world. But it's kind of one way. But luckily, we have another transport stream in Node core called the process standard in and process standard out. It's still just streams that connect you to somebody else. It being, the process writing to you and the process you're writing to. So we can just do this cool thing in here. Instead of, just printing out data, just make this a bit smaller so it doesn't jump. We can just do standard in, pipe to the socket, and then we can do socket pipe process standard out. And since pipe works with any streams, this will work, with any transport. And we can even make this a little bit cooler because pipe actually returns the stream, so we can just do it like this. So we have this really cool, 6-line server that's basically a chat server. You just don't realize it. Because what I can now do is I can start my server. It's called size. I can run this netcat thing again. I can see, hello, Mathias. And it prints it out because, we're piping to send it out. And up here I can say, hi, other Mathias. And it prints it down here again, right? So it might seem pretty trivial, but it's the power of transport streams. It doesn't care what transport it's writing to, as long as it's a stream. And it even works, notice that this down here is not even a Node program, and it works with programs that's not even Node, which is even more cool. So we get, a lot of stuff for free in 6 lines of code. And again, this is production quality. I mean, you don't even need to apply threads or anything. So yeah, let's continue. So distributed systems. So what we actually just wrote was a kind of a distributed system, right? A chat app is kind of distributed systems. It allows me on one machine to connect to another machine and start typing stuff, and I can chat with somebody else. So since it's running on 2 machines, it's distributed. So like I said, I like to travel a lot, and I have a friend who I meet up with once in a while. We usually end up in the same place. And we have this ongoing problem of, who decides who gets coffee or figures out the Wi-Fi code. And, it's a pain in the ass because we're always on our computers trying to work or just do fun stuff. And it's, that whole interaction is something we wanted to save. So we actually met up 4 days ago and we decided, let's solve this once and for all and create a rock, paper, scissors game that we can play using our computers. Then we don't even have to interact anymore using normal analog behavior. How do you say rock, paper, scissors in German? Stein, Sachs? Schere, Sachs, Papier? Stein, Papier, yeah. In Danish it's Stein, Sachs, Papier. I had a guy tell me what it's called in Spanish and was like way off. So, yeah, let's try that. Okay, so cool. Let's just try doing that. So, we're gonna use TCP, right? So we still need the net module. And we're gonna make this a module. Actually, this is the time I now rename this file from size to something else, so I don't confuse myself. Size, rock, paper, scissors. There we go. So we need TCP, and like I said, we're gonna make this into a module. So let's say our module, it's only going to work once, right? It's simple. So what we're going to do is we're going to accept a weapon here. And a weapon is just, it's going to be a string. It's going to be rock, paper, or scissors as a string, right? Pretty simple. And let's accept a Boolean also here. It's called is server, because one of them needs to be a server, because they need to connect to each other. And let's just use a fixed port and IP for simplicity. So how do we do this? Well, we probably need some sort of function called onSocket whenever they have a socket that connects them to each other. And the server and the client are going to do the same thing, so I'm just prematurely optimizing here and putting it into a function. Then we say down here, if it's the server, make a server using same style as our chat program. I'm just going to call the variable s, because then it fits on my screen. And just pass that to our socket function. And let's just say that we continue to listen on 8080. Otherwise, make a client connection and pass that to the onSocket handler. So pretty basic stuff so far. So once these two guys have a connection to each other, I should hit this code block here. So we're just going to make this as simple as possible, right? So what we're going to do is we're just going to send each other what we chose as a weapon, and we're just going to implement the logic of the game. So we have our first problem here because we need to send a message to somebody else over a transport stream. So I could just do stuff like this thing here, but that wouldn't work because our weapon is more than one character, and there's no guarantee that a transport stream will send the entire thing. It might send one byte at a time, right? So what we're going to do here as good Node citizens is we're just going to use a module. And I really like the module called ND.json, which is just a transform stream, not a transport stream, that allows you to send JSON over a socket and pass it. It just adds a new line at the end, so it's a really simple protocol. So I probably need to install that. Got that guy. So we're going to have a serialized stream when we write, and we're going to have a parse stream when we parse. And we're going to pipe this serializer to the socket, and we're going to pipe the socket to the parser. Is everybody following so far? I see some people nodding. So I'm just going to continue. And what we're going to do here is we're just going to take our weapon, and we're just going to write that. So we take our weapon, we write it to the serialized stream. That is now getting serialized using this line here, getting written to the socket. On the other end now, on the remote end, the socket will emit this data that we just sent, and it will pass it to the parser stream, and it will make the parser stream emit a data event. And let's just try to print that out so we don't confuse ourselves anymore. So we have this cool module here. So we can't really run it from the command line, so we're just going to write a quick way to do that. I'm going to call the file bin. And what it's going to do is it's going to require this module. And it's going to have this magic shebang line here. So we can execute it. And we're gonna take the weapon as an argument on the command line. And how you do that is you access this argv array, and you get the third argument, because the first one is node, the second one is the file. That's our weapon. And we need to figure out if we're a server, and we're just gonna say, because we're doing this quickly, that the server just adds a fourth argument. Right. So if there's a fourth argument, then it's the server. Argv length, like that. And then we're just going to call our module like that. Cool. That should work. Famous last words. So I'm going to make the file executable, and I'm going to run rock this guy's server. We added the fourth argument. You can see the first one is node. And this guy down here blew up. Oh, I called it pass, didn't I? Yeah, I had a typo. Typos are like the only thing that crashes my node programs these days, I feel like. Because it's an old version of the same software. Right, okay. So as you can see now, this bottom guy is sending weapon scissors to the above guy, and the above guy is sending weapon rock to the guy below. So in here, we just make a variable called remote weapon. And it's surprisingly easy to implement these rules. So if the remote weapons is the same as your weapon, we're just going to log out tie. And let's just return. Otherwise, just going to switch the remote weapon. So this is always where I mess this up. But if the remote guy chose rock, let's make a function called one and pass a boolean to that if we want. So if we won, we're just going to print out you win. Otherwise, we're going to print out you lose. So if the remote guy chose rock, we have to choose paper to win, right? So we're going to pass in that we chose paper. If the other guy chose scissors, we have to choose rock to win. It's always kind of funny when you write these distributed programs, because it's kind of like distributed programs. You're in kind of two states at once, because there's a local state and a remote state, and you kind of have to deal with them both at once, so you get really messed up in your head. And you only have two cases here. If you write something like BitTorrent, you have n cases, and everything is just weird. So it's kind of like having threads, but there are no threads. It's just people executing the program. And if the remote guy chose paper, we of course have to choose scissors. So far so good. Let's try running this guy again. So server chooses rock, and the other guy chooses scissors, and the rock guy wins, right? So far so good, right? We have a program that works. It's distributed. So there's only one problem with this program. Can anybody see a problem with this program? Anybody?
You cannot continue playing.
Okay, yeah. There's a bigger problem. So in these NSA days, right, surveillance days, it's very easy to cheat in this program, right? Instead of, what we're doing is we're just blindly sending our argument to each other, right? So what I could do is, I could just decide I'm not going to ever get coffee. So I'm just going to change my program to just wait for my friend's weapon to come in, and then I'm just going to choose the one that allows me to win and send back to him, right? So that kind of sucks. The game is broken. Does anybody have any idea how we can fix this? This is classic me where I have a solution, so I'm just being smug about it. All right, so what you can do in this kind of situation is you can just apply crypto, and it works. So, and you always say that, and then it turns out it doesn't work, because crypto is hard, and then you're the fool. But I'm going to do that anyway. So what we can do here is that we have a program where I choose a weapon, my friend chooses a weapon. Kind of have to say to each other, we chose a weapon now, and then we have to exchange them to figure out who won. So what if, instead of exchanging the actual weapon first, we just exchange some sort of proof that tells the other guy that I chose a weapon? And what if he could use that proof when I actually send my weapon afterwards to verify that it was the correct weapon, it was the correct weapon according to that proof, right? Then we could just have a situation where we just first exchange proofs, and then afterwards you can exchange weapons. It's kind of like a very, very lightweight version of how SSL works. I don't know if the NSA has broken this system yet, but worst case, they'll be able to decide who picks up coffee. So what we're going to do is we're going to try to do that. So how do we do that? We require this cool module called crypto. So crypto is one of those modules in Node that you almost never work with, because it seems really hard, and it is hard. And 9 out of 10 times you're doing it wrong, and everything is broken. So how would you make this proof right? How would I be able to send a proof that would allow the other guy to verify that I actually chose a weapon That corresponds to that proof. So does anybody know what hashing is? Right? So hashing is a way of taking a big argument and boiling it down to a hash, a small argument. And it's always the same hash. If you take the same argument, you get the same hash out. So what we could do is we could do something where we could hash the weapon, and we get this string out. That's not the weapon anymore. It's just a string. We can send that. The only problem is it's always going to produce the same hash. So what we can do instead is we can just take some random data and hash that with the weapon. We get another hash out. We can then send this hash we get out. Once we have each other's hashes, we can then safely exchange the weapon and the random data we chose, and then we can verify that that it produces the same hash and that we actually chose the weapon before seeing each other's weapon. So there's actually a crypto way of doing this. It's called an HMAC. So first we need some random data. We call it announce because we only use it once. So how do you get random data? There's a method in crypto called random bytes that just gives you random bytes. Actually, it turns out getting random bytes is really hard, and it's a very hard problem. If you don't have good enough random bytes, everything else is broken. So make sure to use a good method like this. Don't use math random. So what this will do is it'll give me a buffer that has 64 bytes, and they're all random. Then I'm going to produce an HMAC, and an HMAC is just a hash that takes a key and makes a unique hash function, more or less, based on that key. So what we can do is we can just take the HMAC, pass in our nouns, and now we get a hash function back here. We just hash our weapon, and we digest it into a hex string. So let's call this proof instead. That's more fun. So we get our weapon in, we make a nouns, we create an HMAC, we update our weapon in this hash. We get a hash of this weapon and this nouns, and let's just try to console like that and see that it actually does something. So if I run this program again, it didn't work because I have to put an algorithm here, and we're going to use SHA-256 because that's a decent hashing function. So as you can see here, it now produces this proof thing here, and let's verify that it's random. Let's run it again. And as you can see, it didn't produce the same hash the second time, so it's clearly random. Like this hash is different from this hash. We still win though, because we're still sending the same thing, and we're not using the proof for anything. So the only thing we need to do now is we need to update our protocol. So instead of just sending the weapon down here, we're going to send the proof, and don't send the weapon. Then the first time we get some data, we're just gonna get the remote proof. And then we're gonna, now we got the remote proof, then we know that the other guy chose his weapon, and then we can safely, disclose what our weapon was. So what we do is we just say, we write weapon, we send our weapon, and we have to send our nouns also so he can verify it. It's hex here, right? Yeah, cool. So I changed this on into a once because that's just the first message. So if I do a once again, that's going to be the second message. And then I'm just going to take our game and move into this code block here. Right, so we get our proof, we disclose our weapon, then we get the remote's weapon, and we still play the game. But there's one thing missing. We need to, verify the remote's proof. So the remote is also sending his nouns. So what we can do here is we just create a, we just do the HMAC thing again that we did up here, but for the remote's data instead of our data. So this here needs to be a buffer. So we do remote nouns. Use the remote nouns as the key, and then we use the remote weapon. Whoa, it's a pretty long line here, but it's probably fine. So we now have the remote proof, and we just say, you know, if the remote proof is different from the, I had the same variable twice. That's another JavaScript problem. Typos and using the same variable. I'm gonna call it challenge because it sounds cool. So if the proof is different than the challenge, we're just gonna print out your so-called friend is lying. So let's try to see that it is even works still. So I'm gonna spin up the server. It didn't crash, always a good sign. And I still win. And let's see that, you know, if I choose scissors here as well, it's a tie, right? So clearly it's doing something still, it's still working. So what happens if I down here just put in like hacking to this proof? Let's say I send a wrong proof, what happens? It detects that, and that, you know, the friend is clearly lying, right? So we have a game of rock, paper, scissors now that's secure and distributed. So that's awesome. So put this on NPM, and I could be like, so you clearly have the same problem as me where you want to decide stuff and you want to do that using your computer. So I made this game called Rock, Paper, Scissors. And it allows you, shockingly, to play rock, paper, scissors over TCP. And I used to do that in the past, and then the same thing always happens. There's this random guy coming on, and he's like, oh, okay, TCP, that's great, but you know, SSL is better. And also, I have a machine that only can speak HTTP. It cannot do pure TCP sockets, so could you add that also? And I used to be like, yeah, sure, okay, fair enough. You know, you open your computer and you're like producing a lot of code, and you end up with this thing, where it's like, hey, rock, paper, scissors version 2.0, it now works over TCP, SSL, and HTTP, right? And the same thing always happens. Then another guy comes in and like, yeah, so I just invented my own protocol, and it's way better than anything else that you have, and you should probably add that, because otherwise you're an idiot. So clearly this doesn't scale. We can't keep adding all the protocols in the world, right? And I keep seeing these modules all over NPM where people say like, my module supports WebSockets, or my module supports whatever. You know, that's all wrong. You're doing it wrong. Stop doing that. What you want to do is, you want to make a module that supports everything, ever, that's ever going to be here, that's now, ever. Does anybody know how we could do that? We just use streams. All right, so let's make this, let's remove the hack so I don't confuse myself. So if we look at this code here, right, it doesn't really say TCP in here that much. I mean, our entire game is in this onSocket function, right? The only place we ever deal with TCP is down here, where we check, like, is there a server? And if there isn't a server, do this thing. So what we could do is, we just remove this block here and return this function. And then we can just remove the net thing. So now we end up with a situation here where you could pass in a socket here. But it's kind of ugly looking. It's like we're passing in a stream to a function, there's two functions, it's a little too clever. So what we want to do instead is, we just want to return a stream that somebody can pipe to, right? So if we just return a stream, then we get all the niceness of streams, because streams can be piped to other streams, and you could even gzip your rock, paper, scissors thing, because it's just a stream. So how do we do that? Well, as you can see down here, we have this stream called serialize, and we have this stream called parse. And those are kind of like encapsulating our entire game. So if we could somehow return those two streams, that would kind of be our game. So it turns out we can easily do that. So I'm just going to remove this function and fix my indentation. So there's this really cool module called Duplexify. I wrote it. And what that allows you to do is it allows you to take two streams, a readable stream and a writable stream, and duplex them into one stream. And there's a bunch of modules actually in NPM that does this, but it turns out getting error handling right is insanely hard, which is why I ended up writing one. So if you require that, let's install it. Duplexify. If you require that, what you can do down here is you can just say, let's return a stream. I'm just going to move down here so people can see what I'm doing. Return a stream. It's going to be a duplex stream. And when you write to the stream, it's going to write to the parser. So that's a bit confusing. But we have to write, the writable end kind of turns into the readable end because we're flipping things around. And whenever this stream is readable, it should read from our serializer because that's where we're writing stuff out to, right? So we just have to flip those around. So what we get now is we get this really cool interface here now, where this guy just returns a stream. And we can pipe the stream anywhere. So what's the most obvious place to pipe the stream? Standard in, standard out, right? Because it's a command line module so far. So we're just going to take standard in, pipe that to our stream, and pipe that back out to standard out. So what happens now when I run it, first of all, we don't need this stupid server argument anymore because there's no servers, it's just streams. We're kind of just saying, instead of having our module handle the server part, we're just saying the user should handle that. We don't care. So if I just run it, you can see here it's just producing the output to the terminal. So that's not really useful, right? Yeah, so that's not really useful. But how can we turn a program into a command line program that kind of reads from standard in and writes to standard out into a module that supports all transports? Well, we could do something like this where we could remove the standard in, standard out part, and we could just add a bunch of arguments, and it would read those arguments and it would set up that transport. But then we end up in the same situation as before, where we're coupling transports and we have to support everything. That sucks. So we just apply some Unix style, and it just works. So what we want to do is something like this. You have a transport, right? So kind of like before when I used NCAT to chat, I just ran a program and it spawned a command line program when I wrote on my terminal, it sent something to our chat server, and when our chat server replied, it got printed out in the terminal. So it's using standard in, standard out. So what if we had a transport that we could just pipe into standard in, and every time our game was doing something, it would just write it out to standard out, and we pipe it back into a transport. Well, the only problem here is that this is actually kind of hard in Bash because we want those two transport streams to be the same stream. And if it's TCP, we want it to be the same TCP socket. And now we're spawning two programs. So how do we solve that? So me and a friend figured out to solve it in Bash, and it involves 80 lines of Bash because Bash is crazy. Or you can do this magic one-liner where you just randomly hit everything on your keyboard, and it kind of works. So that kind of sucks. So how do you solve it then? Well, you just do the only cool thing, you put it in a Node module, so nobody else has to deal with it, and you put it on NPM. And it's actually really easy to write Node, because in Node you can just spawn two processes, and you can just pipe them together, right, and it just works. So there's this really cool module called DubSH that just does that. So it allows you to write that thing like this, where you just put two programs next to each other, and it will just pipe them together. That's it. Yeah. So what we can do here is we can do something like this, where we spawn rock, paper, scissors, we take a weapon, we spawn another rock, paper, scissors, and these two programs will now play with each other. It's not the most interesting game, because we can kind of look here and see what happens, but it should work. So let's try it. So, do I have DubSH? I do. Oh, that's a good error message. So what I can do is I can take, it's called bin on our machine, and we have the first one pick rock, and we have the second one pick scissors. And as you can see, they're now playing with each other, right? And the best thing about this program is we have no idea who won. As you can see here, it's not deterministic, the order of the output, because we're responding processes, right? So that kind of sucks. But it turns out this pattern is really, really powerful, right? Because I can put anything in there. It just has to be a transport. Anything. So what can we put in there? So Bluetooth guy. The guy who installed my thing, did it work?
I'm not sure, but I installed this stuff, but
Alright, let me just pause it for 1 second. We'll get it back. Also, thanks so much. So, just gonna see if. All right, cool. So, we have a thing that works on any transport, right? We could put any transport in there. So, what's the most simple transport? I just gave it away. It's Bluetooth. So I wrote this program called BLECAT. And it's a one-to-one pipe that connects to computers over Bluetooth. So turns out there are some really good Node modules for doing Bluetooth. And I just put them into a command line module that allows me to run BLECAT on one machine, and hopefully it works. And then on another machine, also run BLECAT. Does anybody want to volunteer and help me so I don't play with myself? Oh, that's actually a really good idea. So, if I write hello here, and if I write hi here, it shows up on the other machine. You just have to believe me, does it? Well, it's probably timed out. Maybe it does, who cares? So it might be working, might not be working. I'm not sure that Bluetooth is correctly installed, but let's just try it again just for fun. Try running BLECAT again. If you cancel that, and then run it again, and then write something to me. Can you come up here and stand? I think this might be. I'm just gonna do the only sensible thing, turn Bluetooth on and off. So if you restart that guy. And I started. Oh, we'll try it anyway. Maybe it works. Okay, so what sometimes works is that we can do stuff like this. Oh, so you need to install npm install rock, paper, scissors. I put it on npm before. Spoiler alert. -g rock dash paper dash scissors slash stream dash dash. Oh, you probably need to. Yeah, so it's on npm. I'll share the links afterwards. We should probably have installed that before, I realize now, but that's the cool thing about doing an unprepared demo. So while we do that, what can I talk about? I can see that I'm not connected to the internet, because that might become relevant afterwards. Cool. Did that work? All right, I'll just show the other demo while we do that. So we got Bluetooth. That might be working. What if we have Bluetooth and we got a Wi-Fi, right? So Wi-Fi is better than Bluetooth because it's higher bandwidth. That means we can play more games. But Wi-Fi sucks because in order to use Wi-Fi, I have to find somebody else and I have to what's your IP? And he's like 10, 2, 2, 1, 2. And you're like, okay. And you try to get your mom to connect to this game, and she's like, I don't even. Okay, 2 seconds. So I got so tired of that, so I wrote a program that solves it. So it's called AirPaste, and it's a one-to-one network pipe that auto-discovers all the computers on the same network. So if you run this on a network that has multicastiness enabled, multicastiness is the cool thing that allows you to find printers normally and iPhones. If you just install AirPaste on 2 machines, or 1 machine for that matter, what you can do is you can just on one of them run AirPaste, and you can even start typing "hello world." And on another machine, you can run AirPaste, and it automatically finds each other using DNS and connects the 2 processes, right? So it's one-to-one thing. So the only natural thing to do is we can use this to play rock, paper, scissors. So what we can do is we can do do.sh AirPaste rock, and then on another machine I can just do AirPaste paper. Oops. Maybe I can do that. Oh, I had to run the other one. And they automatically find each other, right? So we don't need to know each other's IPs. We can just use a transport that just works. So I think that's pretty cool. Unfortunately, multicast DNS didn't seem to work on this network. So otherwise, it's a cooler demo if we have 2 computers. Who cares? Did the Bluetooth thing work? Ish. Oh, you need to install do.sh also while you're at it. Oh yeah. npm install -g. Can you install do.sh? npm install. If you do npm install -g do.sh. Oh, you probably need to sudo it also.
Just check our bank account.
No you there. Well, we all laugh, but everybody is installing everybody's modules all the time, and whoever reads the source code, and then oh, you need to remove the DUP, and then remove that. Yeah, right. Okay, so we forgot to install another program. So while we're doing that, I'll just move on. So we might have Bluetooth working, right? If we're on the same network, we can just automatically find each other. We don't need to exchange an IP using AirPaste. What if we're not on the same network? And the funny thing about this next demo is that it's the most unreliable one of them all. So this might end up. Actually, I have a backup one that might work. You should probably install this other thing also. It's all good. You're getting all the good software. Can you sudo that? I think you need to sudo it. So what if we're not on the same network, right? So what if I'm on one network and my friend is in the cafe next door on another network? How do we connect to each other? Well, it turns out there's this really cool thing called WebRTC. Do people know what WebRTC is? So WebRTC is technology that allows you to peer-to-peer connect to computers without having a central server. And it only works in the browser until I found out that somebody actually took that thing in the browser and put it into a Node module. And it's the most unreliable thing ever. It works like 1 out of 5 times, but when it works, it's really cool. So what I did was I took that module and I put it into a command line tool called Webcat, and it allows you to connect to somebody else over the internet peer-to-peer using your terminal as a transport string. Now we're not going to install that because it takes like 20 minutes to compile, but actually I have it installed here, hopefully. I have it on my machine. So what I'm going to try is, I have another machine in Amsterdam, and hopefully that has Webcat. Oops. 1 second. Man, I messed up all my demos. It's fine, we'll just install it again here. Oh, it's because I downgraded Node. Never downgrade Node. Now I probably need to install it. Ah, okay. I have no idea how that worked. So there's only one problem, right? If you connect to somebody over the internet, I mean, if we're sitting next to each other and we're on the same network, and we both run AirPaste, if somebody else runs AirPaste, I might connect to that guy. But if we're sitting next to each other, I can kind of coordinate it. I can say, I'm running AirPaste now. Can you run it also? And assuming you run it at some at a similar time, like assuming I run AirPaste, if somebody else runs AirPaste now, it will connect to my machine. But if my friend is fast and runs AirPaste, it'll connect those two sessions, right? So that's how it does security. You just have to be fast. It's best kind of security. But if you're connecting to somebody over the internet, this problem is now way, way bigger because the internet is freaking huge. So we can't just take a random peer on the internet because there's gonna be some random dude who's gonna cheat. He's gonna say like you're a liar all the time in our rock, paper, scissors game because he's gonna try to hack the game. So what can we do? Well, everybody who uses GitHub has an SSH key on their machine that's actually on GitHub. So I have an SSH key, which is why I can push to my GitHub. And this little known fact that is amazingly cool is that if you go to my GitHub and you put this magic string here, .keys, GitHub will tell you my public key, which is insane. That's insanely cool because GitHub is using SSL. So that means that if I trust GitHub and you trust GitHub, you can look up my public key and trust that it's my public key. So what I can do is I can just sign a request using my private key, and somebody else will be able to verify it using my public key. So I put that into WebCat. So WebCat uses a distributed architecture to exchange these hashes where everybody becomes a peer, kind of. So what I can do is I can say I want to connect to somebody and I'm going to connect to myself. So I want to connect to Macintosh. And if I put a -a in this SSH session, I'll have my agent up here. So that forwards my SSL key. And I have no idea if this works. I'll be able to run the same command on my server, and hopefully, they found each other. And it's both ways, right? And the cool thing is that this is WebRTC, and WebRTC is actually peer-to-peer encrypted per default, so not even the NSA can intercept our rock, paper, scissors game that we are about to play. So, like I said, the rock, paper, scissors game is on NPM. It's called rock, paper, scissors stream. The reason I put it on NPM is I had to put it on my server. So, what we can do now is I can spawn rock, paper, scissors stream. That's the same program we just wrote. And I can spawn WebCat. And on the remote machine, I can do the same thing. Oh, I need to choose a weapon in the other one. That's fine. Rock. And we just saw that it worked, so it works again, yeah. So we can now play rock, paper, scissors peer-to-peer with each other over the internet. So I think that's cool. Did it install the DubSH thing?
Yes.
All right, so let's try this once, and if it doesn't work, you just have to trust me that it works over Bluetooth sometimes. So what you want to run is, you want to run DubSH rock, paper, scissors stream, like this. And then you want to run BLECat. So now you can see my option there, my choice. So it can be a good player and let me win. Or I guess tie would be the appropriate thing to do. So I'm running it now. So if you type that in and you run it, just type enter. Who knows if this works? So I can see here that we're actually connected over Bluetooth, but I think I can write to you, like we saw before, so probably not going to get the reply. Yeah, okay. So that sometimes works. Who cares? So, and actually, 15 minutes before coming here, I wrote a new one that I didn't. I wrote it on the train together with a friend. I don't have any more here. So do I have time for one more demo?
Yeah.
It's called. It's on my friend's GitHub. It's called TweetCat, and it allows you to make a duplex stream between two computers and Twitter. So can you try running this command? Oh, we already installed it. That's true. So I'll just install it also because I think he updated it. So while I'm installing it, the idea was there's this really cool thing that I discovered one of my friends made called base emoji. So it's basically a binary encoding that uses smileys. So you can take any binary content and you can convert it into smileys, and then you can take the smileys and convert it into any binary content. So the idea naturally was, what if we just post smileys on our Twitter, but it's actually binary data we're sharing with each other. But nobody will know. People will just think we're, really happy to see each other because I put a light bulb in front or something. So you have to run, first you have to run tweetcat -- init, because it has to, you have to have space there. And it opens up Twitter on his machine, and you have to authorize our app and put in a PIN code. So if you run tweetcat, what's your Twitter account? So if you run a tweetcat Macintosh, so just put Macintosh there, you have to put a username, MAF.
It's his computer now anyway.
Yeah. So I don't know if he broke it or not, but so what it does is that it posts these tweets.
Oh, okay.
Did you get my reply? All right. So he probably just broke it. Who cares? I swear it worked before. Just for fun, try downgrading. Just want to try this once, and if it doesn't work, we're done. So if you downgrade to, if you do put like add, you can install install.
We can just play a live game now.
I mean, you're all laughing, and this guy's getting all the cool software. You will be able to play all the time after this. All right, let's try one more time, see if it works.
Fix the project.
Oh, I don't know how I did it. So maybe it's because I'm not online. All right, anyways, you can try that if you want to. How can I see my Wi-Fi? OS X is so great.
So much easier on Linux.
Yeah, no shit. But then I couldn't be all vanity about my computer. I'm not online, that's why. anyways, that sometimes works also. So try that. That's all for me. If you want to talk about peer-to-peer systems, look me up. Thank you.